Hey guys, welcome back to my YouTube channel. This is Ashok. In the last video, we saw what is outliers. We saw a few examples of outliers. Not only that, we saw few of the techniques or few of the steps involved in detecting the outliers, and also few techniques involved in handling these outliers, right? And today in this video, we'll write a sample Python code to understand and implement those key concepts and key techniques which are basically used for detecting and handling these outliers. So without wasting much time, let's dive in. So the standard deviation is represented as something like this, and the formula for standard deviation is 1 by n summation equals to I equals to 1 to n x minus mu the whole square. N is the number of observations, x is the input value, and mu is the mean value. So there is something called as variance. So variance is nothing but square of your standard deviation, right? In that case, the formula for variance will be 1 by n summation equals to I is equals to 1 to n x minus mu the whole square. So basically it will remove the square root, right? Because you are taking the square of your standard deviation. So that is the variance. So variance is always square of your standard deviation. So similarly, the formula for z score is x minus mu divided by standard deviation, right? So x is the data point, mu is the mean value, and this is the standard deviation, which is nothing but this. So next is the IQR, right? Interquartile range. So guys, remember this formula. This is very much important. So you will be getting a lot of interview questions on this IQR, right? So they will ask you about this IQR and interquartile range, and how do you have, what are different terms involved in this one. So this is Q1, which is nothing but 25th percentile of the data set. This is Q3, which is 75th percentile of the data set, and this value will be the median. And this one you are seeing here is nothing but your IQR. So this value is IQR, which is interquartile range. So the formula for IQR is basically, if you can see here, it is Q3 minus Q1, right? Q3 minus Q1 you'll get is IQR. So this is minimum value, and this is basically maximum value. So this one says Q1 minus 1.5 times the IQR. Here it says Q3 plus 1.5 times the IQR, right? So it is on the negative side, and this is on the positive side, right? So the minimum value. So from the Q1, if it is on the negative side, you are minus 1.5 times the IQR, and it is on the positive side, so you say Q3 plus 1.5 times the IQR. And if some data points are lying here, so these data points which are lying below this line is outliers, and these data points which are lying above this one, right, these are outliers. So this is the formula for IQR, interquartile range, Q3 minus Q1. Now let's go ahead and see how these formulas are implemented in Python. So let's implement z-score first. So in the first step, what I will do, I will import this numpy, because I want to do some kind of transformation, some kind of modifications for this particular data, right? So what I'm doing, I'm declaring sample dataset, right, which is nothing but test scores. Let me run this. So in the next step, what you are doing, you are creating a function, defining a function called as calculate z-scores, and passing this particular data set to this function, right? And we know the formula, right? Z-score formula. So we say x minus mu divided by standard deviation. So we know the data, we have the data with us. We need to calculate this mean value and the standard deviation. And how this mean value and standard deviation is calculated by using this formula. So mean is says np, which is nothing but the numpy, which I am imported this library, which says np has this mean value, and then pass this data. Similarly, we can calculate this standard deviation and pass this data, right? So this is simple two formulas to calculate mean and standard deviation. And then at the end, we am returning this z-score. So let's run this. So next step is simple, right? I am identifying the outliers using this z-score, right? So I say z-score equals to same function which I have created here, and then I'm taking something called as threshold. This threshold, right, is equals to 3. Basically what we have is like there is have a 1 standard deviation, 2 standard deviation, and a 3 standard deviation, right? So any data points above than 3 standard deviation, those are outliers, right? So I'll create a separate video on this to understand this threshold, like 1 standard deviation, 2 standard deviation, and 3 standard deviation, right? Basically it is called as distribution of the data, or you can call it as the empirical formula. So we'll discuss empirical formula. During that time you'll come to know what is this threshold. For now you understand what is a 3 standard deviation. So any data points which are lying above this 3 standard deviation, those are outliers. So in the next line, I'm enumerating those z scores and calculating the score, and which is, if score is greater than threshold value, which is nothing but the threshold is 3 standard deviation. If it is above the 3 standard deviation, those are considered as the outliers, and I'm just printing those outliers, right? So let me print this and show it to you. So here you can see z score outliers absolute is greater than 3. So it is, this value is, threshold value is 3, right? So that's what is printed. But the main thing which you need to see here is no outliers detected based on the z score threshold. Now that is because this particular data set doesn't have any outliers. So let me change the data a little bit, right? So let's add this 1000, because if you see the range of the data set, right, it is some within some range. So I have added 1000, which is outside beyond this range, right? So let's run this now. So now you can see this is a z score outlier in our data set, which we added just now, this 1000 value, right? So last time it printed no outliers detected, right? Now this time this is printing, this is the z score outlier, because I have added the outliers in our data set. So now let's understand about IQR interquartile range. So I'll be using the same data set. So what we are doing here is we are defining a function called as calculate IQR, and we are sorting this data, and then we are calculating this Q1 and Q3. We know the formula for IQR, right? So IQR is equals to Q3 minus Q1. So we need to calculate this Q1 and Q3. And how this Q1 and Q3 is calculated? You say np dot percentile value, and this np dot percentile value, right? So this is 25th percentile, as I've told. This is 75th percentile. So Q1 is 25th percentile, and the Q3 is 75th percentile of the data set, right? And I'm returning this Q1 and Q3. Let's run this. So what I'm doing here in this step is identifying the outliers using this IQR, right, interquartile range. So we've calculated this Q1 and Q3. You know the formula of IQR, which is nothing but Q3 minus Q1. And we have to calculate the lower bound and the upper bound just to find out the outliers, right? So we have the formula for lower bound and upper bound. We have Q1 minus 1.5 times the IQR, which is a lower bound. Q3 plus 1.5 times the IQR is the upper bound. So anything below the lower bound and anything above the upper bound, right, those are called as outliers. So now let's run this. So in this particular step, what I'm doing, I'm taking this data and getting this lower bound and getting the upper bound, right? And then I'm printing the data. Let's run this. So you can see this IQR outliers are within this range, right? And then there is no outliers detected based on the IQR for now. Let's change let's modify the data again, right? So let's add this 1000 again here, and let's run it. Similarly, we'll run this, run the IQR, and then this. Now you can see this is the IQR outlier in our data set. So this 1000 which you added, this is an outlier. And also you can see, right, once you add this 1000, so this upper and lower bound also changed, right? So now let's visualize the distribution using this histogram and the box plots we discussed in the last video. So here in this step, I'm importing few of the libraries, right, in NumPy and Pandas, just to do some kind of modification, transformation with respect to the data set. And I'm importing Matplotlib and Seaborn. So these are the very two important libraries for visualization in machine learning, right? So then I'm creating a sample data and converting that particular data into a data frame. And then here in this particular step, I'm visualizing the distribution using the histogram. And in this step, I'm visualizing the distribution using the box plot. And you can see this formula, right? This is calculating the IQR, interquartile range. And at the end, I'm using this logic to visualize the distribution after handling our data sets, how data set will look, how the distribution will look after handling our data set. So let's run this, wait for some time so it is generating. So you can see here, this is the distribution, right? This distribution is without handling your outliers, right? So this is with outliers. So this is the box plot of the data, right? So this is line is the lower bound and this line is the upper bound, right? So any data points which are lying here and any data points which are lying here, these are called outliers. So you can see here, this is the distribution of the data after handling the outliers. These two are before handling the outliers, right? So, and this is after handling the outliers. So you can see there is a slight change in the distribution of the data set. So guys, the task for today for you guys is, you can see the standard deviation variance, right? I want you guys to implement this standard deviation and variance using the sample Python code and provide this particular code in the comment section. I'll go through that and we'll discuss in the next video. Okay guys, that's it from my side for this particular video. So in this video, we discussed about standard deviation, z-score, and the interquartile range, right? And we saw the formula for each of them. We implemented this formula in the Python, and also we saw the distribution of the data set before and after handling of the outliers. Thanks for watching. If you like this video, hit the like button. Please subscribe to the channel, share with your friends. I'll see you all in the next video. Till then, take care, keep learning, and keep rocking.